Hello everyone, in this video I will show you how to model bolt in Ls-Dyna for Ls-Dyna applications. As you can see, I have two plates and they have holes on their middle. I will connect these two plates via bolt. There are different applications to model bolts. For example, RB2 C-bush RB2 or RB3 C-bush RB3 and RB3 C-bar RB3. Modeling technique changes from company to company, but here I will model as RB2 C-bush RB2. The bolt will be located at the center of the holes. Let's first create RB2s. In Ls-Dyna, RB2s can be modeled as constrained nodal rigid bodies. Click on Model and Part from the right toolbar, and then click on Create Entity. From the Constraint tab, select the nodal rigid body, and click on Create. There are two different options to create CNRBs. Here, if you click on Create P node, which is creating the P node, then Ls-Dyna will create a massless node on the center of the selected nodes, and selected nodes will be connected each other via center node. Select the nodes on the circumference for the first plate, and then click on Apply. Repeat the same procedure for the second plate. Select nodes, then click on Apply. Click Done and close Create Entity window. In order to create bolt, click on Element and Mesh from the right toolbar, and then click on Element Generation. From the opened pop-up window, you can see different element types to create. Select the beam, and then select two mode sets from Beam By. Uncheck the Create Part property. When Pick Node set 1 is selected, select first node, and then click on the Pick Node set 2, and select the second node. And then click on Create and Accept. As you can see, our 1D beam has created. You can assign different material properties to this beam, but I will only create section and assign the section to this beam, and then show the beam in the 3D representation. Let's click on Done, and click on Model and Part from the right toolbar. Then click on the Keyword Manager. Select All in order to show all the keywords in Ls-Dyna. Sections can be created by the options under the Section tab. From here, double-click on the beam. Click on the New ID. From L-Form, you can change the formulations for beams, element formulation. I will leave it as default, which is L-Form 1, which means Hughes-Lee with cross-section integration. With this element formulation, you only need the dimensions of the beam. You can also change cross-section type of the beam from CST tab. I will select 1, which means it is tubular. When I click on TS1, it means beam thickness or outer diameter in S direction at node 1. And for TS2, it says for at node 2. While creating beam, I first selected the center node of the upper plate CNRB. So this is our first node. And second node is the center of the lower plate CNRB. Let's enter 20 TS2. Then click on Accept and click on Done. The last step is to assign the section to our beam part. If you know part ID or part name, you can easily assign this section from part and part keyword. But otherwise, you have to select the part from the general user interface. To do that, let's close the Keyword Manager tab by clicking on Done and click on Part Data. From the pop-up window, click on Assign, and from General User Interface, select our beam. From Seg ID, which is Section ID, click on blue word, then select our section and click on Done. And click on Apply. Now let's check the 3D representation of the beam. Let's close this window. From the upper menu, click on View and then Beam Prism. Here is our beam's 3D representation. Modeling beam with Ls-Dyna for Ls-Dyna applications is that simple. Thank you for watching my videos. Please subscribe to the channel for new videos. Stay tuned for more. Goodbye.